everyone. Today I'll be taking you through creating and running a Docker image for your React application. In my last video, we went over how to install Docker and the benefits of using it. So if you have not watched that yet, I will leave a link to it in the description below. To recap quickly, we want to have the Docker desktop application installed that you see in front of you right here. And the reason we want to use Docker is to containerize our application so that we can streamline the build process and ensure they run as expected in different environments. Again, if you'd like to hear in more detail for this, please check out my last video. Before we begin to containerize our application, we need an application to containerize. So let us start by creating a React app. If you have not created your first React application before, I have a video that goes through doing that. I'll leave a link to it in the description below. So to start by creating our React app, let's go into the command line. And from here, we can create our React application by typing in npx create React app, and let us call it Docker React app, as the auto suggestion hinted. Now, this should take a couple minutes for it to get set up and build. Now that we have set up our React application, let's go inside the project folder we just created and open it in our IDE. We can do this simply by just typing change directory and name the application we created, Docker React app. I press tab to autocomplete, and now we are inside the project. And let's open it up in our editor. I'm going to use code period to open this up in Visual Studio Code. The period just symbolizes opening up the current directory. Okay, now that we have our project open, let's open up the left-hand side, go to app.js. And this is more or less what's going to be rendered when we start our React application. It's just a boilerplate. So let's open up the terminal. And here we can start our application by just typing in yarn start. And now this has opened up the development server. Taking a little while to spin up. So let's just move this over to the right. And let's move over our IDE to the left. So to begin containerizing our application, let's actually stop the development server here. And now if we reload here, we should give us a connection issue. And let's start by setting up a new file. There you go. We have to call a dockerfile for Docker to be able to automatically detect the file. If you give it a different file name, we can pass in the tacf flag and then specify which file we want to run when we're running our Docker commands. So in this file, we will create our Docker container layer by layer. And I mentioned the layer by layer part because if there are any changes, then when we rebuild our container, only the layers that have a change will be updated, and this speeds up the build process significantly. So we first define the base image. This is just going to be the starting point for our Docker file, or our container, I should say. And let's use a widely available image. So we're going to say from node, and then current alpine. So in this base image that we're installing, it's a very lightweight distro of Linux Alpine that comes bundled with Node. And we need Node to run our React application. So let us now then specify the working directory for our container, which we will use as, let us say, so the workdir command. And let's just say it as app. What the workdir does is basically just change directory into application. If that folder does not exist, it creates it. Now what we're going to do is we're going to copy the contents of whatever is inside package.json. The star just means match anything after package. So it's package lock, just package into the current folder we are in our container, which in this case here would be application. And then finally, once we have that, we just want to run yarn install. We can also do npm run install. The reason we do this separately is because of the layers I mentioned earlier. We are less likely to install a new module frequently, so these layers should not change often, and as such we can use a previous cache state and speed up the build process. So this means steps 1 through 5, generally speaking, if you make a change, and let's just say app.js, don't need to be recompiled or rebuilt, I should say. If we didn't do this, then every single time we made a change in the source code, we would have to reinstall all the node modules to update our image. And you guys saw the first time we install our node modules, it takes an extra minute or two, so we'd have to put up with that every single time we wanted to start our container. Finally, like we mentioned earlier, we copy over all the contents of the project into our container. So then we just do copy dot dot. That means copy everything from where we are when we execute our docker run command into everything that is inside of the current working directory of the Docker container. And then finally, to get our application up and running, we just do command yarn start. Great. If we were to build and run this image, we should be able to start our container. But before we do that, we should have a .dockerignore file, because you can see some of these contents in this folder don't really need to be copied over to our container. For example, node modules, we're going to be installing that fresh whenever a change does happen in node modules. So there's no reason for us to copy that over. So let's create a .dockerignore file, right? And then let's just have like all files that are not required in our build, right? And let's close this here so we can kind of see this better. That can be dockerfile, right? Because we need the dockerfile to create our container, but we don't need the dockerfile inside of our container. Same goes for the dockerignore. Again, this is just needed to ignore certain files when we're creating our container. Same with the gitignore. And then we want to ignore all the artifacts that will be built during image creation. For the time being, this is just going to be node modules. And that's mostly because, like we mentioned earlier, node modules will be created when we are creating our image, so we no longer have to copy that over. Now that we have that set up, we can continue to starting to build our container. So we should have everything ready to go to start creating the image. So we can do docker build tag t. The T just means tag of the image name. So in this case, let's call it React image, and then period for right here. So now to start building the image, and this shouldn't take too long, but the larger the image files you use, the longer it will take. Okay, so that took a couple minutes to build, and now we should be able to run the image that we created. And we can do that by typing in docker run. And then we want to pass in rm here. The reason we want to pass in rm is when we stop our container, this will delete the container in the processes, so it makes our cleanup easier. We also then want to pass it a port. So the reason we pass it a port is because we want to be able to communicate with our container. By default, we're not able to do that, so we want to be able to communicate to the port 3000 on our end, and let's correspond that to the port 3000 on the container's end. And the reason we're using 3000 is because React app.js by default will connect to that port. And then after that, we just follow it by the name of the image. So in this case, React image. And let's press enter. And now it's going to be starting our development server on the container. Now if we come here and we refresh, there we go. Now we have our React application running on our Docker container. So it's great that we got our app running, but we can notice something interesting here, at least for development purposes. Let's open up our app.js. And right under Learn React, let's say we type in Learn React v2. And if we save it, we don't see those changes on the right-hand side. Let's reload it for good measure. But still, we don't actually see those changes. And the reason for that is in our container, the source code for app.js hasn't changed because we copied over all the contents on our file system to the container. But now when we make a change, we're just making a change to our local file that has not been copied over to the container. For development, you can imagine this getting very annoying. Every single time we introduce any change and we want to see that change actively on the right hand side, we'd have to rebuild our image. And that's just not particularly feasible. So how do we combat that? Let's begin by first stopping our Docker container. So let's open up another one, another terminal right? Let's make this full screen so it's a little easier to read. And let's type in docker ps. Now this is going to show all the processes or the containers that are currently running. And we can see image with React image and then container ID there. So we type in docker stop and then the name of our container ID, B0. We don't have to type in the full container ID name. It's just going to do a match. So as long as it's a unique match, it will match. And of course, we need a space. And there you go. Our container is stopped. So getting back to our original question of how do we combat this? What we can do ideally is we want our container to point to our local source folder, which are usually going to be the files we are most likely to change, like app.js, app.css, any other components, any other files that you frequently change during development. We want to point our container to our local files for those. And we can do that by setting up a local mount, a bind mount for volume storage. And what we're going to do is we're going to connect app source to our local mount. And we can specify that when we run our container. So we can do docker run. Let's keep remove there as well too, because we want the cleanup to happen automatically once the container closes. TAC P, we still want our port 3000 on our machine to respond to port 3000 on the machine of our container. Now we're going to pass in an additional flag. We're going to do .pwd here. This basically gets the working directory path, right? And the reason we need to do this is because the volume storage mount, it requires an absolute path. So you can figure out what your absolute path is, but usually this is going to be an easier way to do it. So an absolute path to the Docker React app, and then we want to specify the source folder to mount. And we want to make sure it's only the source folder. If we mount the whole volume storage, then it's just going to take whatever that was on our volume and everything's going to be read from there, and essentially there wouldn't be much use of our Docker container. And we want to specify app, because that's what we called our working directory, and then we want to say source, because that's going to respond to source inside of our container. And then we also want to pass it read-only. The reason we pass it read-only is this means the container can only read on our local volume storage, but it can't write to it. Generally speaking, the container wouldn't write to files, but we don't even want to give it the option to do so. So this is more of a security check and a safety check. And then finally, again, pass in the image that we are going to use. So now this is starting. Should take a couple minutes. So there you go. Now it's running. If we reload our page, we should see down here, learn React v2. But what if we make some more changes? Learn React v3, we save it, and we can see now, even though our React application is running on our container, it is responding actively to the changes we are making in app.js, and this is going to be great for development. And we have now set up Docker to use during local development. So just to recap what we've done through this video, we created our Docker image, we added only the relevant files to the image, and ran our image with a local volume storage so that only those changes were reflected. So hopefully you guys found this video helpful. If you do, please like and subscribe, and tune in next time when I show you how to set up and run multiple containers using Docker Compose.